Hi, P6 students. Welcome to another video of our Math 6 class. And again, this is Miss Claire. We are now on chapter 7. It talks about number patterns. In this video, you will learn two lessons. We have find and use the position to term rule and find terms in special sequences. Okay, P6, are you excited to learn these lessons? Come on, let's get started. To start with, I have here a picture. Look at these children. There is a triangle table. So there are children that can sit, three children that can sit in one table. How about if they will form the two triangle into one table together? So how many children can sit? Yes, there are four children because it form a square, right? How about that if there are three tables already? So how many children can sit? Yes, there are five. So there are five children can sit with three tables that are formed together. So what have you observed on the pattern of the tables and the number of children? So how are they related? So that is what we call a number pattern, children. So in this video, we will discuss more about different number patterns as we go on. Okay, so stay tuned, P6. Okay, let's start with lesson 1 to find and use the position to term rule. The learning outcome for this lesson is to identify the position to term rule of a number sequence and to apply the position to term rule of a number sequence. Look at this picture. I have here some cards. How many slanting cards are there on level 4? And how about the base cards? And also, how many cards are there on level 4? So to find the number of cards on level 4, you need to find first the pattern for level 1, level 2, and level 3. So look at the pattern. So once you get the pattern, it will be easier for you to get the number of cards for level 4. So if you know the answer P6, you can try or you can give your answers during our class, okay? Okay, I have here another problem. Let's form the number sequence using number of bonds. So we have number of trays. So the number of trays will represent the position. Then the number of bonds or total number of bonds is the term. So as you observe, to get the number or the total number of bonds, we just simply add 5 to each trace. So we have plus 5. So this is our constant. So this is the difference between from one term to the next term is adding by the constant of 5. So to get to the next term for the fifth term or to the sixth term, we will add 5 from the previous term. So if you want to get the total number of bonds for the sixth term, you will add 5 to the fifth term. We can also multiply its position by 5 to get the terms. Let's say the position is the 5 and we will try to get the sixth term. So we will multiply it by 5 times 6 and we will get 30 bonds altogether. So our n here is our number of trays. So number of trays multiply the number of bonds. So that is equal to the total number of bonds. So our position to term rule here is 5 times n or 5 bonds times the number of trays. Another problem we have here using number of seedlings. What have you observed here? We have our position, the number of pots, and our term, the total number of seedlings. So we have a missing number of seedlings here and missing position. Look at the first term. We simply add 1 plus 2. So that is to get the first term. To get the second term, we will add the first term by 2. So 3 plus 2 or 1 plus 2 times 2. So we multiply the 2 by 2, then plus 1. To get the third term, so we have third term, we multiply the 3 times 2 or the 2 times 3 plus 1, we get 7. To get the fourth term, we also have 1 plus, we will multiply the 2 by 4 because we are looking for the fourth position, and that is 9. So the fourth here is our position, the 9 here is our term, okay? So 4, our position, times 2, the 2 here is our constant, or the constant, and that is the number that we always use if we are going to go to the next term. So therefore, to get our term to position to term rule, we are going to plus, we will use this term, we are going to use this term to position to term rule, 1 plus n times 2, where is the n is our number position or our position. Since we are looking for the for this one, the fifth one, so 5 times 2 plus 1, that is 11. Okay, so that's how to find that position to term rule. Okay, we have now lesson B, find terms in special number sequences. The learning outcome is to identify and extend a sequence of square numbers and also find the terms in sequence of square numbers and also recognize cube numbers. Look at the pattern here. These are square numbers. If our diagram will continue, how many dots are there in diagram 5? Okay, so these are our terms. So we have the first term, which is 1, second term is 4, third term is 9, and fourth term is 16. So how can you describe the position using the position to term rule? Correct, we multiply the term by itself, 1 times 1, 2 times 2, 3 times 3, and 4 times 4. Simply multiply the term or the position by itself. Okay, so following the pattern, so if we will continue, guess if there will be a diagram having 81 dots. Is there any pattern or diagram? Try to look for the square numbers from 1 until 10 and try to find out if there is an 81 number. Okay, let's continue. We have Ron stamps, figure 1, figure 2, 3, 4, and 5. The stamps here or the squares here represent the stamps. What have you observed in its figure? Yes, to get the number of stamps, we need to multiply the stamps by itself, right? So to get the total number of squares. So the total number of squares, therefore, this is our position to term rule. To get the square number, we multiply the position by itself. 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. So if we are looking for the number 10 or the figure 10, simply multiply 10 times 10, and that is 100. So is 75 a term in the sequence of square numbers? Is there a number 5 in our square numbers? Okay, try to look for after 25. So let's say 6 times 6. That is 36. Please continue if you can find 75. Okay, look at this picture here. I have here a purse. The designs in each purse are flowers. We have here 65 flowers, or 64 flowers for the first one. 64 is a square number of 8 squared, that is 64. 81 is 9 squared. And 100 is 10 squared. If we continue this sequence, what will be? What are the numbers? How many numbers are there in the next two purses? So it means 11 squared and 12 squared. So 11 times 11 is, yes, 121. And 12 times 12 is 144. So these are the next two purses. We'll have this number of flowers on their pattern. Okay, P6? Now, let's study about cube or square numbers. So, a square numbers again is the result of a number multiplied by itself. So, 1 squared, 2 squared, 3 squared, 4 squared. So, these are square numbers. Now, let's study about cube numbers. Cube numbers, P6, is the result if we multiply a number by itself 3 times. So, if we have 1 cube means 1 squared times 1. You can square it first, then times one more time by itself. 2 cube is 2 times 2 times 2. 3 cube is 3 times 3 times 3. 4 cube is 4 times 4 times 4. So the cube numbers are 1, this is 1, this is 8, this is 27, and this is 64. So these are cube numbers. So if we continue the pattern, what will be the next? If we have 5 cube, okay, and that is the next slide. Take a look here. Okay, George arranged 1 centimeter cubes to form larger cubes. There are 5 1 cm cubes along each side of the larger cube. So how many 1 cm cubes are needed? So it means like this. On one side, there are 5 cubes. And on the other side is 5 cubes. So this is the first layer. So 5 times 5 is 25. That is the square numbers, right? 5 times 5. When we see cube, we multiply again on here, in here. So we have 5 layers. 5 on this side, 5 on this side, and 5 layers. That is 5 times 5 times 5, and it will give us 125. So we need 125 small cubes to make the larger cubes. So this is what we call cube numbers. Okay, P6? Okay, P6, that's all about number patterns. I will discuss more about this lesson during our class. And I hope that you learned a lot in this video. Thank you for watching, and always remember to stay safe and healthy. God bless everyone and have a great day.